Welcome back to part 2 of chapter 12, lesson 4, comparing sets of data. Now when we left off, we had increased each data value with the same exact amount, 5, and we saw what that did. Now we're going to do something different. This time we're going to increase each of the data values by the same percent. In this case, it's going to be 10%. And we're going to find out what that does to our data set and if the same rules apply as we got when we increase it by the same exact amount. Give you a little spoiler here, they don't. So let's dig in and see what's going to happen. So we're going to take and see if I can get this up. Oh, I am on the wrong screen here. Now we can do what we need to do moving forward. We're going to start off with the same exact data set before, which was Tom's earning before earning an extra 10%. He has the same median, he has the same mode, he has the same range, he has the same mean, and he has the same standard deviation. We good so far? Now we're going to take that and we're going to add 10% to every single data value. So when we do that, we're going to see that the median shifted up $5, just like it did when we added 5 to each thing. But as you recall, the mode shifted up to 57, went from 52 to 57, but here my mode shifted up to 57.2. So now my mode is different. It's not the same as what I got last time. What else are we going to find? Well, we're going to find that the range is now going from 68.3 minus a 44, which is going to give me a range of 19.8. That's different than what we got last time. How about the mean and the standard deviation? Well, the mean is different. It's 53.5, but we expected that. But how about that standard deviation? It has actually increased. There's more variance between how much he's going to earn every day with an increase of 10% than there was when he increased by $5. Let's take a little bit further here. Notice that each value did not increase by the same amount, but did increase by the same factor of 1.10. When we increase by 10%, that means you're increasing, they're getting the next pay, he'd get 110% of what he got the previous pay. And of course, change 110% to a decimal, that means you multiply each of the values in this graph by 1.1 or 1.10, and that gives you the values in this graph. That's what that means right there. Thus, the mean, the median, and the mode all increased by a factor of 1.1. So, if you were to take and multiply the mean, 50, by 1.1, you would get the 55. If you multiply the mode, 52, by 1.1, then you're going to get the 57.2. And if you took and multiplied, what was the other one they said for us? The median, which, I gave you the mean earlier, but the median of 48.6 by 1.1, that gave us a 53.5. So now instead of adding the same amount to each one, we're actually multiplying the same percentage to each one. Since each value was increased by a constant percent and not a constant amount, your range and your standard deviation change, also increasing by a factor of 1.1. So that means that if we were to take the range of 18, multiply that times 1.1, that should give us 19.5. If we were to take the standard deviation of 4.9, multiply that by 1.1, that's going to give us a 5.4. So going back over what we had earlier, if we were adding the same amount, the mean, the median, and the mode all increased it by that k value, which was 5 in that previous problem, while the standard deviation and the range stay the same. But if we're increasing each value by percentage, the same percentage, then you take every one of these over here, multiplying by the 1.1, and that's going to give you all of these over here without having to do the calculation of finding each one of those individual data points. Let's keep it going. Key concepts: if every value of a data set is multiplied by a constant k, where k is greater than 0, then the mean, median, mode, range, and standard deviation of the new data set can be found by multiplying each of the original values in the statistic by the same k. Easy enough? Really, it pretty much is. Let's see what else they've got for us. Since the medians for both bonuses are equal and the means are approximately equal, should Tom ask for the bonus that he thinks? Let's see. Tom should ask for the bonus that he thinks he has the best chance of receiving. So what are they saying? They're saying that the median value did not change. He had 55 median, whether he got a $5 increase or a 10% increase. So the median middle value he made is going to be the same. And what else did it say? The means, the averages are approximately the same. I don't remember what the average was for the first one, but the average for the 10% is going to be 53.5. They were very close to each other too. So with that in mind, it says, since they're both basically the same, Tom should ask for whichever one he thinks he has a better chance of getting. Give you a hint, people are bad at math. So if you ask them for a $5 range, they can calculate that $5 raise real easy. Ask them for a 10% raise, they're going to have to think about that one. So maybe you do better one way or the other. Let's keep it going. So example number 2 wants us to find the mean, median, mode, range, and standard deviation for this data set obtained after multiplying each value by 3. Okay, so this one may end up being somewhat different too, but I think it's going to be just like the last one, where if you multiplied each of the numbers, you're going to get the increase. So find these and the standard deviation of the original data set is the first thing we're going to do. So in doing that, they're going to take and get you, and just use your calculator. We've shown you how to do it multiple times. You found the mean was 16, the median was 16.5, the mode is 12, the range is 12, and their standard deviation ended up being 3.7. You got all that using either your handheld graphing calculator or your Desmos calculator. And then if you were to take and multiply each of these data values by 3, well, then your 16 became 48, your 16.5 became 49.5, and so on and so forth, all the way through there. So instead of having to multiply each individual data value by 3 and finding the mean, median, and mode of it after you did that, all you had to do was find the original data values and then multiply each one of these mean, medians, and modes by 3, and that gave you the new mean, median, mode, range, and standard deviation. Pretty simple overall. Recall that when choosing appropriate statistics to represent data, you should first analyze the shape of the distribution. This is going to be the same when comparing distributions. Remember, if it's symmetric, we're going to use the mean and the standard deviation. If it was not symmetric, we were going to use the mode, which was going to be one part of the 5-number comparison that we were going to do. I think called it a 5-number survey. So let's see what they've got for us here. Use the mean, that's what they said, and standard deviation to compare two symmetric distributions. So we're going to be looking at two distributions that are symmetric. Or use a 5-number summaries to compare two skewed distributions, or a symmetric distribution and a skewed distribution. So the only time you're going to use the mean and the standard deviation is if both of the distributions you're comparing are symmetric. If they're both skewed, or if even one of them is skewed, then you're going to have to use the 5-number summaries. Now it's going to be time for us to get in there and start playing with those graphing calculators again. We're going to be comparing Robert and Elaine's quiz scores for the first semester of Algebra 1. And Robert's quiz scores are here, Elaine's quiz scores are going here. I already programmed both of those sets of quiz scores into my graphing calculators in order to save us a little bit of time. So, what are they telling us to do? They're telling us to do a strange road of getting here. I'm not necessarily going to use their road, but when we do it, we should find that we have a graph that looks like this for Robert and a graph that looks like this for Elaine. Watch what happens when I do it though. So I put in all of my data, and I'm going to jump back over here, and when I graphed Robert's quiz scores, that's what my graph looked like, even though I had the same exact values. Why was mine different than what they had? Well, it's because of what the range was on the x value, how many, what scale they used for the x's. So I had to play around with it for a while, and I found out that if I was to take and change my x scale, which is right here, from 1 to 4, and now I was to take and plot it, I'm going to get the same exact chart that they did. That gives me the chart for Robert, which that looks like a pretty symmetric chart to me. Does it look like a symmetric chart to you? I think it does. All right, so let's take a look at Elaine's chart. That's going to be the next one. So to do that, I'm going to hit second. I'm going to hit stat plot. I'm still on plot 1, and you can see here where we've got plot 1 is turned on. We've got the bar or the histogram has been selected there, but I need to change the X list. So to do that, I'm going to highlight that. I'm going to hit second. I'm going to go to my stat button, which has my list, and I'm going to scroll down and hit enter to change to list 2. So now list 2 is the one I'm referencing. From there, I can hit my graph button, and now you're going to see, for some reason it looks like it took graph 1 and graph 2 and combined them. I'm not sure why that happened. Let me see if I can figure out how to make graph 1 go away. I think I see what the problem is. If I went back to my stat plots, you can see plot 2 is turned on, listing it as list 1. So I'm going to go down to plot 2. I'm going to hit enter. I'm going to turn off plot 2. And now, if I hit my window, all it's going to show me is Elaine's graph. Once again, that's a very symmetrical graph. And since both of their graphs are going to be symmetrical, which type of measures should we be looking for? We should be looking at the mean, and we should be looking at the standard deviation. Because anytime you have both charts being symmetrical, you want the mean and the standard deviation. So, how are we going to find that? Well, for that, we'll go ahead and throw down the next slide here. Both distributions are high in the middle, low on the left and right. They are symmetric, and therefore, once again, we're going to take and look at the means and the standard deviations. Now, if you recall, that is super simple to find. All we have to do is jump back over to our graphing calculator. We're going to hit our stat button. We're going to go to the right and hit calculate. And I'm going to do one variable. Which list do I want first? I'm going to hit second, list. I'm going to choose L1 and hit enter. And right here, I've got a mean of 84.7 and a standard deviation of 7.5. So we're going to jump back over here and let's see what they gave us for that one. And they're going to give us a mean of 84.7 and a standard deviation of 7.5. Now we're going to do the same thing for Elaine's quiz. So we're going to go back, and this time I'm going to hit stat. I'm going to hit the right arrow to calculate. I'm going to hit 1 for one variable statistics. Oops, wait a minute. I need to clear something out here because it didn't do right for me. So let's see if I hit stat again, go right arrow, hit enter, and then now I have to hit the second and the list, which is right there. And I'm going to scroll down to list 2 and hit enter again. And this time we have a mean of 84 and a standard deviation of 4.6. What did they get? They get a mean of 84 right here and a standard deviation of 4.6. We can do all this on the Desmos calculator as well. So I'm going to bring that up because that's what y'all are probably going to be using. And I'm going to clear out the stuff that we used earlier. Get rid of that, get rid of that, get rid of that. And, whoop, here we go. So I've got list 1 and list 2, which are the same list we were using with them. And we want to find those stats. We want to find the mean and the standard deviation. So to do that, first thing I'm going to do is I'm going to add a function right here. The function I want is going to be, well, let's find the mean first. And which one do I want the mean of? X shift underscore 1. And, whoo, something didn't work out right there. That's F1. Oh, that's why, right there. Those two numbers should be separate. So I'm going to delete that 89. I'll just put that 89 down here at the end. And now when I come down, I get the mean of 84.7, and is that what we got here? 84.7. Then to find the standard deviation, I'm going to take and hit function. I'm going to go to, remember, we don't want standard dev, we want standard dev population. I'm going to hit x underscore 1 again, and right there it's the standard deviation of 7.5, which is the same thing they got here. To find out what Elaine scores are, all I have to do is go back to this one, change that to 2, and Elaine has a mean of 84, and change that to 2, Elaine has a standard deviation of 4.6. So once again, using the Desmos calculator really does make this finding the solutions to this data easier, at least for now, than the handheld calculator does. The handheld calculator is going to give you more information at one time, but most of that information is stuff that you don't need yet. So jumping back to our information, what have we learned? We have learned the means of the students' quiz grades are approximately the same, 84.7 and 84. Yeah, Robert's got her a little bit, but not that much. Robert's quiz scores, however, have a much higher standard deviation. Robert had a standard deviation of 7.4 or 7.5, while Elaine was 4.6. What does that mean? It means there's more consistency in Elaine's quiz scores than there are in Robert's. Robert's has some high numbers where he does great. He has other numbers where I guess he played football all night or video games all night and then came in and bombed the quiz, and they just kind of balance out to be this average. Whereas Elaine, she gets pretty close to the same scores every single time. Next, we're going to play with the box and whisker plot, but we're going to come back on video 3 to do that because this video I think is probably long enough as it is.